Hey everyone, and welcome. Sound is everywhere, right? It's the music we love, the conversations we have, even just the quiet hum of a room. But have you ever really stopped and thought about what sound is? Well, today we're going to break it all down.
So let's just dive right in with the big one. What exactly is sound? It seems like such a simple question, doesn't it? But the answer is actually really cool and takes us on a little trip into the world of physics. To get to the bottom of it, you really only need to understand one single concept, because at its core, every sound you've ever heard boils down to one simple thing: vibrations. When you really break it down, sound is just a vibration, a wave of energy. And the key thing here is that it needs something to travel through. It can move through a solid, like when you hear footsteps in the next room, through a liquid, or, what we're most used to, through the air. If you don't have that matter, you've got nothing. Okay, so if sound is a vibration, how does it actually get from, say, a speaker all the way to your ear? Well, it happens through this amazing little chain reaction between molecules. So picture this. It all starts with some kind of movement. You clap your hands or you strike a gong. That action immediately makes the air molecules right next to it start to vibrate. And then those molecules bump into their neighbors and make them vibrate, and on it goes. It's literally like a wave of dominoes, passing that energy along until it finally reaches an eardrum. But what would happen if that chain reaction had nothing to, well, react with? Imagine I'm talking, but there are zero molecules between me and you. Could you hear me?
Exactly. You wouldn't hear a thing. It would be total silence. This is why there's no sound in the vacuum of space. There are no molecules up there to pass the vibration along. The chain reaction has no chain. So, the biggest takeaway here is, no matter, no sound. Period.
All right, so we get what sound is and how it travels. But how do we explain the differences between, a high-pitched whistle and a low bass note? That brings us to how we actually measure sound using terms you've probably heard before: pitch, frequency, and volume. Let's start with frequency. The easiest way to think about frequency is just how fast something is vibrating. It's a count of how many of those sound waves, those little ripples of vibrating molecules, go past a single point in a certain amount of time. It's pretty easy to visualize, actually. A high-frequency sound has waves that are all scrunched up close together, so a bunch of them pass by every second. A low-frequency sound, on the other hand, has waves that are way more spread out and lazy. And here is where it all clicks into place with what we actually hear. Why does this all matter? Because the higher the frequency, the higher the pitch our brain perceives. The two are directly connected. Think about a guitar. When you pluck that really thin, tight string, it vibrates incredibly fast, right? That's a high frequency, and we hear it as a high-pitched note. But that big, thick, heavy bass string, it vibrates much more slowly. That's a low frequency, and it gives you that deep, low-pitched sound. And finally, we have volume. This is probably the one we're all most familiar with. It's just how loud or intense a sound is, and we measure it using a unit called decibels. Simple enough. Okay, now this is where things get really mind-bending. What if I told you that right now, this very second, the world is absolutely filled with sounds that you can't hear at all? Let's talk about the sounds that exist completely beyond our own ears. See, our ears are amazing, but they do have their limits. For most people, we can only hear sounds that fall between about 20 Hz on the low end and 20,000 Hz on the high end. You can think of this as our own little window into the gigantic universe of vibrations that are happening all around us all the time. So anything vibrating slower than that 20 Hz cutoff is called infrasound. The waves are just too slow and spread out for our ears to even pick them up. Some animals, like elephants, actually use these deep rumbles to communicate. But we use it too. Scientists listen for these ultra-low frequencies to detect things like earthquakes and volcanoes. And on the other side of the scale, anything vibrating faster than 20,000 Hz is called ultrasound. The pitch is just too high for us to hear. Animals like bats and dolphins use it to navigate. And of course, we figured out how to use it in medicine. Those ultrasound machines that let you see a baby in the womb, that's just high-frequency sound waves creating a picture. It's incredible. And before we wrap this up, here's one last fun fact for you. Sound waves are not like light. They don't have to travel in a straight line. They can actually bend and flow around things. It's the reason you can hear someone calling for you from another room, even if you can't see them. The sound just kind of spills around the corner to get you. So I'll leave you with a thought to chew on. Right now, wherever you are, the world is humming with sounds both too low and too high for you to ever notice. It makes you wonder, right? What invisible symphony is playing out all around you, just beyond the edge of your hearing?